Recognizing outstanding parts makers provides an opportunity to raise the bar, to chase innovative ideas, and to work together to harness the full potential of this advanced manufacturing technology. Now it's time to present the grand prize winners as voted by this year's judges. GKN Sinter Metals and customer Pierberg received a grand prize in the automotive engine category for conventional PM components for an outer gear rotor. This dry sump pump outer gear rotor for an Italian luxury sports car is made from a metal matrix composite aluminum alloy that contains aluminum nitride ceramic particle reinforcement with an apparent hardness of 70 HRB, a tensile strength of 325 megapascals, and a rotating beam fatigue strength of 100 megapascals. It is the first PM aluminum outer gear rotor using dual material aluminum steel pump gears for a production vehicle application. The gear rotor is solution heat treated and artificially aged for optimum mechanical properties. The unique material system retains high strength at the 150 degrees Celsius operating temperature. The inner profile of the gear rotor for this high performance application was critical for it to function in conjunction with the steel inner rotor with a different thermal expansion coefficient. The geometry was optimized through collaboration with the customer. The matched thermal expansion with the aluminum housing provides benefits across a wide temperature range, from the coldest to the hottest operating temperatures. The part provides a 50% reduction in rotating mass, which becomes even more significant with 6 gear rotors per gang pump assembly. Kairim Metal Company Limited and customer Hyundai Motor Company received a grand prize in the automotive chassis category for MIM components for a rotary wheel. This aesthetically pleasing to the eye, touch and feel rotary wheel customizes the driving experience through ease of selecting various internal functions in high-end internal combustion engine and electric vehicles. The component is made from MIM 316L stainless steel to a 7.6 grams per cubic centimeter density, has an apparent hardness of 67 HRB, a tensile strength of 520 megapascals, and a tensile elongation of 50%. The 81mm diameter of the wheel is rather large for MIM, and a hot runner system was employed to improve the flowability of the feedstock to ensure a full fill was achieved. 4 fan-shaped gates were used, equal to the number of side cores. The gas generated where the feedstocks met was vented to each slide core to control possible injection defects. Overblocks in the inner part of the cavity improved the flow mark, prevented defects, and acted as ejection panels. A plus or minus 0.1 mm roundness and flatness requirement was met without secondary operations. The MIM components have 4 times the durability and 0 discoloration or damage that was observed in the prior electroplated plastic parts during service. Additionally, the MIM process reduced material waste by 30% because the previously electroplated plastic parts gates and runners could not be recycled. Divergent Technologies Incorporated and customer Zinger Vehicles received a grand prize in the automotive chassis category for metal AM components for a brake assembly chassis structure. This brake assembly chassis structure, along with over 350 other components, was designed entirely by artificial intelligence, adding material only where it was required, according to topological optimization design software. Due to the uniqueness of these components, tooling and machining of such features would not only be a daunting task, but also economically unfeasible. The ultra-lightweight chassis structure for this hybrid system, consisting of a mid-mounted twin-turbo 2.9-liter V8 and e-motors for each of the front wheels, is made by laser beam powder bed fusion. A multi-material concept is utilized, ensuring components with specific loading conditions meet their requirements. Using a proprietary high-performance aluminum alloy, the material has a yield strength of 265 megapascals, an ultimate tensile strength of 330 megapascals, and an elongation of 21%. The mass has been reduced by over 25% from many of the components that were already designed for higher-end, lightweight vehicles. Full vehicle validation was completed and the component passed accelerated durability and proven ground abuse, dynamic stiffness, noise vibration hardness, as well as various federal motor vehicle safety standards. These ultralight components are designed to have a lower carbon footprint throughout its life cycle compared with those manufactured using conventional techniques. Indo-MIM Private Limited received a grand prize in the lawn and garden off-highway category for MIM components for a rotor flow meter. Used in an agricultural sprayer, this rotor flow meter is used to measure the flow rate of pesticide or fertilizer that passes through an extended boom on either side of a carrier while spraying a field. The component is made from MIM-17 pH stainless steel, has a yield strength of 730 megapascals and an ultimate tensile strength of 900 megapascals. It has 8 blades angled at 45 degrees around the circumference and a sectional thickness of 0.64 millimeters. A single cavity mold is used with 4 side cores. To ensure the side cores had reasonable strength, the 8 blades are formed using 4 side cores, with each side core making 1 full blade and halves of 2 other blades. A diaphragm gate at the center was provided for uniform filling. Since the positional tolerance of the blades with respect to the central hole are important, special staging was used for sintering to produce the part without distortion. The outer diameter is 32.9 plus or minus 0.03 millimeters with a positional tolerance of 0.02 millimeters and a thickness of 6.5 plus or minus 0.05 millimeters. Previously machined, MIM provided a one-piece rotor consistently at a substantial cost savings, and all sprues and risers are recycled and reintroduced into the process. ARC Group Worldwide and customer Palmetto State Armory received a grand prize in the aerospace, military, firearms category for MIM components for a fire control housing. The fire control housing mounts into the frame of a pistol firearm and supports various fire control mechanism components, including the trigger. It facilitates the assembly of the firearm and supports the sear and blocker that are safety components. Made from MIM 4605 low alloy steel, the component is sintered to a 7.5 grams per cubic centimeter minimum density. It is subsequently ferritic nitrocarburized in a salt bath to achieve an apparent hardness of 35 HRC and a tensile strength of 1380 megapascals. The component is molded in a 2-cavity tool with multiple slides. The housing features a date code, multiple through holes, and strategic gate location on the back of the component to maximize material flow. Constrained tolerances on the rib features were critical to control, necessitating a synergy between tooling strategies and sintering tray design to eliminate the need for sizing. Several through-hole diameters are designed to plus or minus 0.04 millimeter tolerances. The one-piece MIM housing fulfilled the function of multiple parts. All sprues and risers are 100% recycled in a zero-discharge facility where no wastewater is released into the environment and air quality is closely monitored. Indo-MIM Private Limited received a grand prize in the medical, dental category for MIM components for a curved jaw. This proprietary stainless steel curved jaw is part of a new advanced bipolar energy laparoscopic device used for tissue sealing that increases procedural efficiency and provides stronger sealing and better access to more tissue. The device is used for colorectal, gynecological, bariatric, and thoracic surgery procedures. Designed for MIM, molding this component without defects was a challenge due to the thin wall thickness in a few areas and obstructions to material flow associated with the complex part design. Preventing short fill in the 6 miniature blind bumps was difficult since localized inserts and air vents could be used in this area. Innovative tooling design and special mold heaters were utilized to ensure uniform filling of this part with its multiple complex features and blind spots. Special sintering supports were required to retain part shape during debinding and sintering. State-of-the-art optical measuring equipment was used to measure critical parameters prior to shipping. 3DEO Incorporated received a grand prize in the medical dental category for metal AM components for a clevis. The primary component in a wristed end effector assembly used in robotic minimal invasive surgery. This clevis interfaces with multiple components to enable controlled articulation of remote surgical tools inside the body. A hybrid metal AM approach is used to make the parts that offers the robustness and accuracy of CNC machining and the scalability of MIM. A thin layer of metal powder is spread, followed by a binder agent onto the entire layer indiscriminate of part location. A precision micro-end mill cuts the perimeter and internal geometry of that layer. These steps are repeated until the components are fully formed in the build and then placed in a sintering furnace. The material is MIM-17 4pH stainless steel with an apparent hardness of 34 HRC, a tensile strength of 1000 megapascal, and 6% elongation. The component exceeds 99% density after sintering. The clevis features 6 through holes. The 4 smaller holes contain the driving cables that transmit force from the surgeon down through the hypodermic tube and inside the body, ultimately coupling with the wrist mechanism to provide 8 degrees of freedom to the end effectors. The 2 large holes contain insulated wires that allows cauterization without switching tools. The development cycle for this application was reduced from 12 months to 3 weeks. ARC Group Worldwide received a grand prize in the Electrical Components category for MIM components for a stator assembly. This stator assembly, comprising a plate and frame, is used in small aerospace servo valves for flight control actuation. The stator assembly is part of a flux-carrying device that delivers magnet and coil flux to an armature. Both parts are produced using two-cavity, three-plate injection molds. Strategic tool design, venting, and innovative binder systems allow complete material fill of the complex geometries. The plate is made from MIM 316L with a proprietary binder formulation to ensure even and complete sintering with minimal distortion. The part sinters to 99% relative density with minimal distortion and does not require hip processing. Minor machining is required on the bottom and top surfaces to maintain profile and hole positions. The two screw holes are reamed and threaded and have screw thread inserts added to provide strength in the final assembly. The parts are passivated for corrosion protection. The frame is made from a soft magnetic iron-nickel alloy to a density of 8.1 grams per cubic centimeter. The magnetic field is heavily dependent on the dimensions of the part as well as the magnetic properties of the base material. A proprietary sintering process followed by hip processing is used to guarantee material properties. Previously, the non-MIM assembly required excessive machining and grinding processes to meet the print requirements, adding time, inventory, and cost. Indo-MIM Private Limited received a grand prize in the Hand Tools Recreation category for MIM components for an anti-drill door lock core. This quick-change anti-drill door lock core is used in a high-security door lock assembly. The component requires high strength and good wear resistance. It is made from M2 tool steel, heat-treated to an apparent hardness of 58 HRC with a tensile strength of 900 megapascals. The parts are electroless nickel-plated and can withstand 240 hours in a salt spray test. The cube-like structure has 4 square through holes and across its center has 3 cylindrical projections, one at each edge and one in the center. The 12 by 9 by 10 millimeter part has several thin wall thicknesses. The complex part geometry requires complex tooling. Parts are molded in a 4-cavity tool. The rib-like structures are susceptible to weld lines and short fill due to the thin walls, so a central injection point and hot runners were used for better material flow during molding. Sintering staging shutters were used to retain part shape, and the parts were oriented parallel to the direction of gas flow to avoid distortion at the center of the rib area. Ladies and gentlemen, these are the winners of grand prizes in the 2022 PM Design Excellence Awards competition. Please join us in saluting their achievements as we invite company representatives to come to the stage to accept their awards.